All right, in the next part of section 1.7, we're looking at how to solve inequalities involving absolute values. So now that I have inequalities, instead of having two separate equations, I have to think about a range of values. So let's look at this properties of absolute values inequalities box from your textbook and try to figure this out. So we're going to so we know A is a positive number. So let's let A be 5 just to look at this. So if absolute value of x is less than 5, that says the distance between x and 0 is less than 5. So x could be here or here or here. It could be anywhere along here between 5 and -5. So that distance, if it was an equal sign, it would be right here, be equal to 5. But since it says less than 5, it's somewhere between -5 and 5. That distance is small. So when I have a less than sign, that tells me that distance is closer to 0. So, and then since it's strictly less than, I have these open parentheses telling me it is that distance is within 5 units of 0, but it is not equal to 5. Now what if I go to the next one and I get absolute value of x is less than or equal to a? Well, it could still be less, it could still be 4 or 3 or 2 or 1 or -1 and -2. That distance is still within 5 units of 0. Oops, that should be a 5. But now we can also, since it has an equal sign, it could also be exactly 5 units away, or a units away. So to show that I can be exactly, I'm going to use these closed brackets on my interval. So the open brackets shows me it is not equal to that value, but it's all the way up to that value. And closed brackets tell me that it can be equal. It's less than or equal to. So I'm just to say includes equal. So equals an option. All right. So when we have a less than sign, that means we're between 2 units. The distance between 0 and that other value for whatever a is less than a or less than or equal to a. So we have one section for less than signs. All right, what if I have an absolute value that is greater than? So we're going to use our 5 for an example. So if absolute value of a is greater than 5, that tells me that it can't be close to 0. It can't be 1, 2, 3, or 4. It can't be -1, 2, or 3. It's too close to 0. That distance is greater. So you have to go at least 5 units out before you can start. It's not equal to 5, so we have open brackets, so it could be 5.1 or 5.0001, but anything starting right after 5. It is greater. So you walk 5 units away from 0 in either direction, and then once you get to 5, your next step is a possibility for x. So x could be anything that is further than 5 units away from 0. And again, with our equal sign, the only thing we change is the closed bracket. So this one includes includes 5, includes the equal option, and this one does not. This one's not equal. So my open bracket's not equal, my closed bracket means includes equal. All right, let's apply this to a problem to solve. Okay, actually, before I do, let's summarize. So when I have greater than, that means I'm going to have to draw 2 separate intervals. Okay. Let's look at example. This is our 4th example for section 1.7. Let's do 3 minus x absolute value is less than 2. Okay, so with less than, that means I'm doing a interval that the 3 minus x is between, it's that distance is less than 2. So that value, it could be a negative also. So it's between -2 and 2. So that is this first example here. So on the number line, it looks like between 0, well, actually, the 3 and the x, wherever the x is, it could be over here, it could be over here, that distance is less than 2 units. Okay. So now to solve this, I'm going to treat it like a equality, a equation with a single variable, a linear equation, that's what I was looking for. And I want to isolate the x. So the first thing I want to do is get rid of that 3. So I'm going to subtract 3, but now instead of both sides, I now have 3 sides to subtract a 3 from. So -2 minus 3 gives me a -5. And then these 3 cancels, but I'm still left with a negative x. And then 2 minus 3 gives me a -1. Now here's something a little tricky. I have to multiply this whole thing by a -1, which means I got to flip everything. Take the opposite of everything. So I'm going to multiply everything by -1 to get x to be positive. So the 5 becomes a positive 5. The less than sign becomes a greater than sign. The negative x becomes a positive x. The less than sign becomes a greater than sign. And the -1 becomes a positive 1. Now this inequality is in a kind of funky order because I want to go from inequality with less than, I want to do less. I want to go from least to greatest. So, sorry, that should be a 1. So 1 is less than x is less than 5. So just to get to ascending order, I'm going to put that as my final answer. But the directions say to express this in interval notation. So since it's a strictly less than, no equal, I'm going to have an open brackets, and it can range anywhere from 1 to 5. And that's my interval notation for this. 1, so 0's over here, 2, 3, 4, 5. That's the interval notation showing this on the number line. So open brackets means it's not equal to 1 or 5. And it's all the space between 1 and 5. So x is anywhere between 1 and 5. Now let's do one where we have a greater than or equal sign, like 3 or 4. So let's do example 5. Let's do absolute value of 3 minus x. And let's do a greater than or equal. Let's do equal this time so that we get a closed bracket. So we're changing the sign from a less than to greater than. And how does that work out? So let's look at our table over here. Remember, when we have a greater than sign, that means we have our interval has 2 parts. So I need to express that in 2 parts, or 2 inequalities. So this tells me that either 3 minus x is greater than or equal to 2, or 3 minus x using this part of that table up there. Whoops, sorry. So the thing in the absolute value is either greater than or equal to 2, or it's less than or equal to -2. So I'm using this formula right here to rewrite those two inequalities. So this inequality has 2 parts. Now solving both of those, I can do 3 minus x, getting the x by itself. I'm going to do subtract 3 from both sides. I'll rewrite that equation next to it. Actually, I'm just going to start over. Okay, 3 minus x greater than or equal to 2. Subtract 3 from both sides to isolate the x, and I get negative x is greater than or equal to negative 1. And I got to flip everything because I have an x as a negative, so take the opposite of everything. So x becomes positive, this becomes a less than sign, and this becomes a 1. And let's do it over here on this equation now. 3 minus x is less than or equal to negative 2. I get subtract 3 from both sides. I get negative x is less than or equal to negative 5. And flip everything to make it opposite, so I get a positive x. Flip the sign so it's greater than or equal to. And change the negative 5 to a 5. So here's the two pieces of my solution. So, okay, I'm going to try to keep everything on the page here. Let's see what that looks like on a number line. So x less than 1. So I'm going to do 0, 1, 2, 3, 4, 5. I'm going to make it a little longer. So 0 less than 1, if I have it in that order, less than means I go follow this direction. So I go that direction. I'm going to do that in red. And it has an equal sign, so that means I'm going to fill in that dot or do a closed bracket, either way. The brackets are usually used for the interval notation, and usually if I'm graphing it, I just do a closed dot, whereas this one I would have done an open dot. An open dot for, wait a second, how did it go? Between the 1 and the 5. That was the previous problem. Okay, so for this one, do a closed dot since it can be equal to x is greater than or equal to 5. Follow that direction. It's greater than, and it's going to have a closed circle at 5 since it can be equal to. How does that convert to intervals? It goes from negative infinity all the way up to 1. It can include 1. There's a closed dot, so I do a closed bracket. And it can also go from 5, including the 5, so I do a closed bracket, all the way to infinity. Infinity you can never include, so I do an open bracket for infinity. And I link these by saying a union. That is a union sign, which says that x could be in this or this. Union is an or. Okay, so example 4 we did a less than, and in example 5 we did a greater than. When we have a greater than, then we're going to end up with an answer that has two parts, so we'll need to use a union to link those two parts. Use your closed or square brackets to show that something is included. Open brackets show that it's not. You can have, just like we have here, you can have an open bracket on one side and a closed bracket on the other side, showing that 5 is included but infinity is not. Another example, something like this. Let's see, this is -2, 0, and a 3. So that's a little number line. Then I would express this interval as a closed bracket around the -2, going all the way up to 3, but not including 3. All right, so that wraps up 1.7. And that's it for today.